In week 3, we learnt about various metals that can be printed. We talked about how powders of these metals are created, what are various stages of powder creation. We talked about two atomization processes, plasma atomization and gas atomization. We looked at what type of powder sizes can be created using these processes, also compared them with water atomization. We discussed about various advantages and disadvantages of these atomization processes and which metals can be atomized using these processes. We talked about that as well. We learned that typically finer powders can be created using plasma atomization because a higher amount of energy involved in that, and also the powders are smoother when created using plasma atomization. We discussed about various alloys that are being used for creating additively manufactured components. We also discussed about applications of these alloys. Also, we learnt about how these elements, oxygen, nitrogen and hydrogen, can be detected in the build components and what is the concept or working principle of these instruments. We discussed about the concept of particle size distribution and how it is applied to the metal powders used for additive manufacturing. We learnt about the instrument which is used for measuring the particle size distribution. Also talked about various morphologies that can be possible using various atomization. We talked about the morphology and the powder quality that we get from plasma atomization and the powder quality that we get from gas atomization. We discussed about more properties of metal powders, for example, chemical composition and why it is important, what is powder size and distribution like mentioned earlier, what is morphology and how it affects the overall build quality. We discussed about how flow rate affects the material property or the build property, what is apparent density, how it is measured, and tap density and how it is different from the apparent density. We learnt about reuse of powders and how it can lead to cost efficiency and sustainability of additive manufacturing, and we also learnt how reuse of powder can help maintain the quality of the parts that are being made. However, there are always some challenges in powder reuse. Also there are challenges related to morphology, contamination of powder and mixing of powders when multi-material components are being made. We also learnt about how it can be ensured that the powder that is being used is of the required quality. We learnt about mill test certificate which comes with the packaged powder. We learnt about which elements are provided in these mill test certificates or the mill test report, water content, skeletal density, morphology of the powder, particle size distribution, chemical composition. These certificates have what are the units in which these properties are measured, which method has been used to measure these properties, what are the prescribed limits in which these properties should be there so that the particles or the powders are of the good quality. We also learned what is the test result of this particular powder. Also we learned that if there are changes in the specification or the requirements of the powder, how it can be updated within MTC.
Hello everyone, let us see the summary of polymer materials and other materials in additive manufacturing. In this we have initially seen about why polymer materials are popular in additive manufacturing. We have seen its versatility, lightweight and cost effectiveness, because of which it is very popular, and we have seen three different categories of polymer material, that is thermoplastic materials, thermosetting plastic materials and elastomer materials. and we have seen in detail about all the thermoplastic, thermosetting and elastomer materials. What we have seen in the case of thermoplastic is detailed classification of this material itself, that is general purpose, engineering grade and high performance. These are some common materials, and the other thing is flexible and elastic material, and finally we have seen soluble material. In the case of general purpose material, we have seen polylactic acid, acrylonitrile butadiene styrene, acrylonitrile styrene acrylate, polyethylene tetraphthalate glycol, polypropylene, and in the engineering grade we have seen nylon, polycarbonate, polyoxymethylene, polyethylene, polymethyl methacrylate and PVC. And in the high performance category, we have seen polybutylene terephthalate, polyether ketone, polyether ether ketone, polyether ketone ketone and polyetheramide. And in the case of flexible and elastic material, we have seen TPU material, thermoplastic polyurethane and styrene ethylene, butylene styrene. And in the case of soluble material, we have seen polyvinyl alcohol which is soluble in water, and we have seen HIPS, high impact polystyrene, which is soluble in limonene solvent, and again we have seen BVOH, which is butadiol vinyl alcohol copolymer, which is again soluble in water itself. After this, we have seen different type of thermosetting plastic materials, and we have seen that all the thermoplastic materials are photopolymer resins, and we have also seen that there is no common name for this thermosetting plastic material. That means in the case of photopolymer resin, what we have seen is there are different elements which is available in the thermosetting plastics, but when it comes to the photopolymer resin, different ranges of these materials are added into it, where we have seen epoxy, acrylic, polyurethane, vinyl ester, phenolic resin, cyanate ester. These kind of elements are added based upon the requirement of the application. So these are some of the application based resin names. One is draft resin, clear resin. That means draft in the sense we will be getting a we can use that material for draft purpose, that means prototype purpose. Clear resin provides a transparent visualization purpose. Tough resin, which has got good toughness with it. Durable resin, which has got high durability, and rigid resin has got rigidity with it. Flexible resin got flexibility with it. And this is how the material composition is maintained by the manufacturers of the materials, and we have seen how the different materials, that means different elements composition is changing with respect to the application of, or the material name. And finally we have seen about elastomer materials in the thermoplastic, that is thermoplastic elastomers. We have seen silicone, nitrile rubber, then polyolefin elastomers, and finally polyamide, that is a flexible one. We have seen the polyamide in the thermoplastic material, that is nylon, and as well as here they are adding some extra plasticizers or modifying the chemical structure, through which we are getting a flexible polyamide which just doesn't have a high level of flexibility with it. After this we have seen about other materials. Under that we had ceramic materials. In this category we have seen about different materials like alumina, zirconia, hydroxyapatite with respect to different industrial applications, and also we have seen its manufacturability with respect to different machine brands and different technologies, and its material form also, where we have seen hydroxyapatite and tricalcium phosphate is mainly used in the medical and dental industry, and cemented carbide being used in the energy sector and industrial application for drill bit manufacturing, and alumina being used for high structural strength applications, and even as an insulator, and even zirconia is being used as an insulator in the electronics industry. So, we have seen one such peculiar material called aluminum nitride, which acts as a heat sink here. And then we have seen polymer reinforced with fibers. One is having a continuous fiber, the other one with chopped fiber we have seen. And then we have seen a smart polymer materials, which in that case we had one material called shape memory polymer, which actually memorizes its shape with it during the printing process. And by providing, if at all we make any deformation, by providing the stimulus like heating, it can able to regain to its original shape. Then we have seen self-healing polymers, which could able to heal by itself, because of which we could able to get a good lifespan. Then we have seen food materials, where almost all the food materials are done through material extrusion technology. People use chocolates or cheese, sauce, and even cakes, they get it manufactured through the material extrusion technology. And we have seen wax material being used rigorously in the jewelry industry, where they use it through the VAT photopolymerization technology, and then get the jewels manufactured through the investment casting. Then we have seen about construction materials, where people build buildings or even pre-structured elements in a particular space, and then get it assembled using cement or mortar or any kind of construction materials. Then we have finally seen different type of biomaterials which are available in additive manufacturing. How the biomaterials are used in different kind of applications also, whether it is a medical implant or a tissue regeneration kind of application or a drug delivery kind of systems. So with this we are coming to the end of the summary. Thank you for watching this lecture.